Yeah, hello everyone. This is Luyi from East China Normal University. Here I will give a short introduction to our work. Are current benchmarks adequate to evaluate distributed transactional databases? This is a joint work with OceanBase. With the rapid development of distributed transactional databases in recent years, there is an urgent need for fair performance evaluation and comparison. In order to analyze the ability of existing benchmarks to support these databases, we first explore the representative architectures of distributed transactional databases. DBMS is usually made of three layers: query layer, transaction layer, and storage layer. Setting a cutoff line between different engines and distributing the down-level engines yields three typical architectures. That is short nothing model with separation of compute and storage, and a short storage model. We need to consider the ability of the current transactional benchmark to support the existing databases as we face the increase of data and an increasing number of distributed transactional databases. And here we arrange these databases and existing transactional benchmarks according to the chronological order. It is obvious that most of OLTP benchmarks are proposed before 2010, while the prosperity of distributed databases starts from its dawn around 2008. So it is urgent for us to explore whether current benchmarks are still applicable to evaluate these databases and their choke points. At first, we explore the choke points of these databases from three layers: transactions, queries, and schedules. For transaction layer, databases have to face three difficulties when transactions scale to multiple nodes. That is concurrency control among transactions, commit management, and the ratio of distributed transactions. For query layer, distributed query processing is popular in a distributed cluster, which meets two main challenges. The first is to provide a global snapshot to guarantee data consistency among different nodes. All distributed databases provide users with a global snapshot except status. The second one is some pivotal features of the distributed databases the pivotal features of the distributed databases all to be taken into account in the face of query optimization. For schedule layer, it covers the functionality of elastic computing, adaptive splitting, and the storage movements. Here, we would like to explore the supporting capabilities of current transactional benchmarks in terms of the choke points of distributed databases. And we classify it into macro benchmark, application-oriented benchmark, and purpose-oriented benchmark. Macro benchmark cares more about the performance of a sub-component. Here, we mention two popularly used macro benchmarks. That is AS3AP and YCSP plus T. And then we take YCSP plus T as example. It is an extension of YCSP. YCSP plus T provides six types of transactions by wrapping zero-RD operations. Specifically, do transaction scan transactions may cause distributed queries. Do transaction read modify writes updates two rows each time, which may introduce distributed transactions. YCSP plus T sets the data access distribution by C-file distribution, which may create contention and adaptive splitting. Besides, with a closed economic scenario, YCSP plus T determines whether the consistency constraint is satisfied by counting the total amounts of all counts before and after business execution. Application-oriented benchmarks reflect the business logics. We introduce and explore 5 popularly used classic benchmarks designed for specific applications. Here, we take TBCC as example, which simulates a warehouse-centered order processing application. There are 5 transactions in TBCC. New order and payments are likely to cause a distributed transaction, but the ratio and cost road number is low. Besides, TBCC requires database to pass through consistency testing. Purpose-oriented benchmarks are designed for simulating the specific characteristics of applications. We study small bank and Tbench. Here we take small bank as example, which evaluates different serializable protocols under a snapshot isolation. There are 5 types of transactions in small bank. In specific, transaction amalgamates transfer the total balance in checking and savings of one customer to the balance of another customer, which may cause distributed transactions spanning at most 2 nodes. Additionally, 90% of transactions involve one customer who is selected from a fixed portion of customers, which can lead to hotspots. Therefore, the processing ability of contention and automatic data splitting may be evaluated. Here, we summarize supporting capabilities of these benchmarks with respect to the choke points in the layer of storage, query, and schedule, and the details can be found on our paper. In the experiments, we explore the performance on the different distributed transaction ratios and contentions, which attracts the most efforts in transactional databases design by extending TBCC. This experiment shows the throughput of new order on OceanBase by adjusting distributed transaction ratios. When distributed transaction ratios range from 1% to 20%, the throughput drops dramatically by 21.6%. It's demonstrates that different distributed transaction ratios have great influence on performance, which should be taken seriously in benchmarking distributed transactional databases. This experiment shows the throughput of TBCC on OceanBase by changing data access distribution of warehouse ID. The access distribution covers uniform and C5 distribution with parameters in different value. The throughput drops obviously by 86.6% from uniform to C5-1. It shows that contentions do affect performance easily, which should also be taken into consideration in benchmarking. In this paper, we provide a comprehensive review of several transactional benchmarks about their applicability on evaluating distributed transactional databases, and we can achieve the following conclusion. For contention, YCSB plus T, TATP, small bank, and Tbench are good choices. For distributed transactions, none of them can control the ratio of distributed transactions and the number of spanning nodes. For distributed queries, user can use YCSB plus T, TBCE, and Tbench. For computing elasticity, Tbench is a good choice. To sum up, on one hand, existing benchmarks can be altered for evaluating some aspects of the choke points. On the other hand, considering the evolution and maturity of distributed transactional databases in the future, a new benchmark exploring all the trade points together is imperative for promoting both developments and fair benchmarking. That's all. Thank you for your time and listening.